right. There we go. Have fun.
Thank you.
Hello, everyone. Welcome back with the final session for the serverless track at Dev Days Europe 2022. With me is Dotan Horovits. He's a software... He's a software developer advocate at Logs.io. And what I see is that you're all about openness and transparency, Dotan. Your bio says open source, open standards. The community is also open. So I guess you'll take us on a journey telling a lot of stuff on observability. Can you tell us a little bit about the Open Observability podcast that you run?
Yeah, I have a podcast. It's all on all the favorite apps. It's about open source, DevOps, and observability in particular. It's in English, and if you like podcasts in general and the topic DevOps and related in open source in particular, then do check it out. Open Observability, one word, talks.
All right. Well, you're very active, CNCF Tel Aviv, and also DevOps Days Tel Aviv. So you're you'll take us on a journey with observability in CI/CD pipelines, right?
Yes, that's the topic for today.
Yeah.
Great.
So with that said, let's get started.
Thank you very much, Alex, and thank you
Enjoy, everyone, and see you at Q&A again.
Thanks, Alex. Thanks a lot. And glad to be here. And as Alex said, today I'm going to share with you how we gained observability into our CI/CD pipeline. And I'd like to start with a day in the life of a developer advocate, DoD. At least in our company, the first thing in the morning, you start the day, you go into Jenkins, you check the pipelines, you work with Jenkins on the CI, and you look at what went on, at least in the last few hours, to know if you're good to go, if you can drink your coffee calmly. Is it red, especially if you have ever read master? And to be honest, sometimes people forget to check, to go in and check, which is an issue in its own right. And if there is a failure, then you need to go into the runs one by one and understand which failed, where it failed, how many failed, why, and so on. In particular, you want to know if it's related to the code that we just released, the new version of the service, or if it's environmental, like a memory leak or high CPU that on the CI/CD machines and things like that. And as I said, you need to go one by one. We have different pipeline runs, the backend, the app, the smoke test, and so on. And then you start comparing to understand the pattern across the runs, across the branches, and so on. And also no easy way to compare with past runs. So that's the experience in a nutshell, just to show you a few examples of questions that we needed to answer as part of such investigation. Did all runs fail on the same step? Did all runs fail for the same reason? How many failed on that reason? Did the failure occur on a specific branch or maybe on a specific machine? Which failed the most? About the times, if something takes longer, is that good? Is that not good? What's the benchmark even? These are the sorts of questions it took us too much time and effort to answer, and we realized that we need to improve. A word about myself. Alex introduced me, so very briefly, Dotan Horovits, developer advocate at Logs.io, been around as a developer, a solutions architect, a product manager, and again, inviting all of you to check out the Open Observability Talks podcast. Or if you're on Tel Aviv, then check out the CNCF meetups. We have it monthly. And let's go back to the story about improving. But before improving on the CI/CD, first let's understand what we need to improve on. And that's something very important that many teams seem to overlook. And for that, I found the DORA metrics to be very useful. For those who are not familiar with the DORA metrics, it started as a research by the DevOps Research and Assessment, DORA, together with Google Cloud, to understand what makes high-performing teams. And then 3 years ago or so, in 2018, they published a book, the Accelerate book, in which they identified 4 key metrics which indicate the performance of DevOps teams, or in general software development teams. So if you want to improve on anything related to your software release, it should map to one of these 4. So just to go briefly over: deployment frequency, which is how often an organization successfully releases to production; lead time for changes, or sometimes it's called cycle time, which is the amount of time it takes a commit to get into production, so all the way from first commit to deployment. Then there's the change failure rate, which is the percentage of deployments causing a failure in production. And lastly, the MTTR, or mean time to recovery, which is how long it takes to restore service after the failure has occurred in production. So again, if you want to test yourselves and improve, make sure that you understand what you want to improve on. In our case, it was the cycle time, or lead time for changes. We realized that it takes us too much time within the CI/CD pipeline that delays the release, a successful release to production. And as I mentioned, I work at logs.io. At logs.io, we provide cloud-native observability platform. So everything we do day in and day out is collecting logs and metrics and traces and putting them all in one platform, and then visualizing and alerting and understanding where issues occur in production systems. So as people who are into observability, we realize that in this case as well, we're missing observability, plain and simple. Now, to be honest, as I mentioned, we worked with Jenkins, and Jenkins did provide us with some observability. We had an option of monitoring performance per step for a specific pipeline. So if you click on in Jenkins and you get into that specific run, then you can see the step by step, and for each step you see the duration on that step. You probably know that. And we also wired Jenkins to get alerts on Slack for failure and things like that. But that wasn't good enough for us. We wanted to find a way to monitor aggregated and filtered information from all the pipelines runs across all branches, all machines, in order to see the full picture and to scale the time range, compare historical data, and filter according to our demands. So it wasn't enough for us what we got from Jenkins. We decided to develop our own observability. And when we broke down what we needed out of the observability, we came up with these 4 main items. First, we wanted dashboards with aggregated views to see, as we mentioned, across pipelines, across runs, across branches, and so on. Also, we wanted the ability to easily compare with historical data so that we can understand if there is a history, is a pattern, and so on. We wanted reports and alerts so that we can automate as much as possible. And lastly, we wanted the ability to view flaky tests, test performance, and their impact on the CI/CD pipeline. So now that we understand what we wanted to achieve, let's get into how. And we at Logs.io have a lot of expertise and experience with the Elk Stack, Elasticsearch, and Kibana. We use that in production. We offer that as a managed service as part of our log management system. So we started naturally our journey with Elasticsearch and Kibana. And the way to get observability goes through 4 steps: collect, store, visualize, and report. And I would like to go over each and every one of these and show you exactly how we achieve that. And everything I show here, you can do as well. So it's going to be very useful for you. First step, collect. For that, we essentially instrumented the pipeline, the Jenkins pipeline, to collect all the relevant information about that run. And we stored it, we put it in environment variables. We chose environment variables. Of course, you can do other means. The most important is to capture everything that could be relevant for your investigation. So we collected the branch, the commit char, the machine IP, the run type, for example, whether the run was triggered by push to branch or merge to master or maybe a scheduled one, the failed step, the duration of the step, the build number, the pipeline status, whatever. Everything that we could instrument, we collected. So that's the collect phase. And after collect comes store. And for that, we created a new summary step at the end of the pipeline, where we ran a command to collect all these pieces of information we put in environment variables, and we created a JSON with a pipe with that data and stored it on Elasticsearch. In our case, as I mentioned, we have our own managed Elasticsearch. Actually, recently we moved to OpenSearch, but back then it was Elasticsearch. But it works just the same if you have your own Elasticsearch or any Elasticsearch compatible solution. The principle remains the same. And I want to say one thing about the aspect of persistence. As I mentioned, we worked with, and we still work with Jenkins, and we tried the built-in persistence that comes with Jenkins, and unfortunately, it wasn't enough for us. Jenkins by default keeps all the builds and stores them on the Jenkins machine, which obviously burdens these machines. So the recommendation in the community is to delete all builds to save disk space on the Jenkins machine. And there's even a Jenkins plugin for that, a post-build step. It's called the discard all build, where you can configure the number of days to keep builds, the max number of builds to keep, and so on. But as I mentioned, that wasn't enough for us. We needed more powerful access to historical data. Historical data is critical for us, and this helps us understand if we have a recurring problem, allowing our teams to quickly identify both the problem and the solution by dates, by failure, and so on. And with Jenkins, we were limited to as far back as Jenkins allows. So we didn't have the control. And we wanted to persist the historical data in our control, to control the duration, the retention, and as I mentioned, most importantly, off of Jenkins servers, off of the critical path. So it's not to load the critical path. So that's on the store phase. And after we have everything, all the pipeline run data in Elasticsearch, then it's very easy to build Kibana dashboards and visualizations, as you probably do for your production environment. And I remind you the questions we found hard to investigate before, like did all runs fail on the same step? Did all runs fail for the same reason? How many failed on that reason? Did the failure occur in a specific branch, on a specific machine, and which failed the most, and so on? So these questions dictated and determined the types of visualizations that we decided to create in the Kibana dashboard. So I'll give a few examples just to show you what kinds of visualizations we created and the power that you can do, of course, flexibly depending on your needs. For example, checking the top level, how stable the pipeline is. For that, we created the success and failure rates, both in general or at a specific point in time. You can see the two different visualizations. You look at these, very clearly you understand if you're in a good state or if you should be concerned and go straight into your Jenkins and start digging, or into your dashboard. Next up, finding problematic steps. For that, we created the failures segmented by pipeline steps. And again, once it's aggregated, it's very clear to see that the specific build step is the pipeline step is the problematic one that you need to drill down into. So finding problematic steps and detecting problematic build machines, something that occurred quite a few times. Some people maybe not properly cleaning up after a run, some memory leak, some CPU, something like that loaded this specific machine. So for that, we created this visualization, failures segmented by machine. And trust me, it saved a lot of time wasting looking for bugs in the released code. Instead, when you see a machine that is overloaded like that, you just kill the problematic machine, you let the auto-scaling spin up a new one, and you start clean. So very useful for determining whether it's environmental or code-based failure. And actually, it was so significant that we created more visualizations. I'll touch on that later. And the last example, duration per step, as I mentioned, to understand if we have long runs, to understand where time is spent. Before collecting our CI/CD pipelines data, we could monitor, as I mentioned, per step on specific runs. So Jenkins does allow that. If you click the run, you see the steps and you see for each step the duration. But again, it's a specific run. And we wanted to find, I just remind you what we talked about before, an aggregated view to monitor aggregated and filtered information to see the patterns across pipeline runs, across branches, across machines. So this is something that was very useful for us. So these are different examples just to give you a taste of the power of visualization that you can create once you have the data in Elasticsearch. And after the visualize step, there's the reports phase, right? And again, reminding you what we had before, the DoD, the developer on duty, needed to remember to manually enter Jenkins and check the pipelines. Now, as a DoD, you get a daily start of day report on Slack, 8 a.m., and it's even better because, as you can see on Slack, you get a snippet of the dashboard embedded within the Slack message. So you don't even need to go into the dashboard in many cases. Just by looking at the snippet, you can already see if you're in a good state or if you should be hurrying up into the dashboard and digging things up. So it definitely improved significantly our quality of life. And this is a scheduled one, but obviously you can define alerts on the data, any triggered alerts with complex conditions on any of the fields that we collected before. So if sum of failures gets above X and the average duration goes above Y, dispatch an alert. Essentially anything you can define as a Lucene query, just as you would in Kibana manually, you can then automate as an alert. And this, by the way, is done with the alerting mechanism we built on top of the Elk stack and on top of OpenSearch. And another point that I wanted to mention is that we used Slack for this case, but it actually supports many other notification endpoints, such as PagerDuty and OpsGenie and Microsoft Teams and many others. So it really depends on the way that your team works. In our case, Slack was the choice, but definitely quite flexible. So that's how we created this Kibana dashboard to get observability into the Jenkins part. But let's remember, CI/CD is more than Jenkins. So we looked at what we can do beyond. One very prominent case that we tackled is to analyze flaky tests and test performance. So repeating the same process, I won't repeat, but collecting the relevant information from our test runs, storing it in Elasticsearch, and then we created this Kibana dashboard. And then you can see the test duration and the failed tests and the flaky tests. You see the failure count and the, what is it there? The failure rate and moving average and failed test by branch over time and flaky test suites over time and so on. So it's really a powerful visualization. And after visualize, as before, you have the report. Same as before, we set reports and alerts. So we got it into Slack. As you can see, pretty cool. So following the same flow. And also, once the data was there in Elasticsearch, different teams started creating different visualizations over the data to suit their needs and the style. So this team, for instance, went to the other extreme. They didn't like the graph. They liked the lists, the ordered lists and the counters. Still a very powerful graph, different style. So that's the power of having the data already in the centralized data, canonical data, but the visualizations could be very flexible depending on the team. So just to summarize what we've seen, 4 steps for gaining observability: collect, store, visualize, and report. Collect was instrumenting Jenkins pipeline to collect the relevant data and put it in environment variables. Then at the end of the pipeline, we created a JSON with all that data and stored it in Elasticsearch. Then we created Kibana visualizations on top of that data, and lastly, created reports and alerts on the data. That's a journey, and very, very useful one. But then what's next? So I showed you how we visualized per step duration using Kibana and did the aggregations. But what if we want to investigate the performance of specific pipeline runs? That's what distributed tracing actually is for. So, and we use distributed tracing for production. So for us, it was a clear fit, and we decided to visualize jobs and pipeline executions as distributed traces. A quick word about distributed tracing, just because I know that not everyone is as fluent with that new discipline as they are maybe with Elasticsearch and logging and things like that. So distributed tracing helps essentially pinpoint where failures occur and what causes poor performance in microservice architectures, in production systems, not specifically for CI/CD pipelines. Because in microservices, every request coming into the system flows through a chain of interacting microservices. And then people start asking, where did the error occur? Where did the performance degradation occur? Was the critical path? These are the sorts of questions that distributed tracing comes to solve. And the way it works is that each step in the pipeline, in this case, emits what's called a span. You can think about a span as a structured log in a way, which includes context like the trace ID, the start time, the duration, the parent span, and so on. So these are the spans, and the spans are emitted, and then you have a backend that collects the spans and reconstructs the full trace based on causality, and then visualizes it, typically with the timeline view that you can see on the left-hand side here, this Gantt chart, that makes it very clear to see that if A, B, C, D, E are the steps, then A is the root, your initiator, that it takes the full span, the full time. But then you see that A called B. Shortly after B started, it called C. When C ended, then D started. And then when D finished, E started. So you really see the flow. You see how much time was spent on each of these steps. You can see which steps ran in parallel and which one sequentially. So it's a very, very powerful tool. And we worked with it for our monitoring our production environment. We worked with Jaeger. I don't know if you know Jaeger. It's an open source. We have it also as a managed service as part of our suite. So we naturally chose it also for our CI/CD observability. And just in a nutshell, if you're not familiar, it was developed by Uber. And then it was open sourced and contributed to the CNCF, the Cloud Native Computing Foundation. It graduated from the CNCF in 2019. It's used in production. I'm not going to say too much about Jaeger in this scope, but if you are interested in hearing a bit more about the history of how Uber came to invent Jaeger and how they used it at their scale, then I highly recommend and invite you to check out a podcast episode I did on Open Observability Talks with a member of Jaeger, Uber team that worked on Jaeger. Distributed tracing at Uber scale. That's the episode. Highly recommended. So now that we understand what's distributed tracing and we know a bit about Jaeger, let's talk about the flow. And again, it's the same flow as we talked about before. Collect, store, visualize, and report. So for the collect phase, we chose OpenTelemetry for collecting. OpenTelemetry, if you don't know, very quickly, it's an open source also by the CNCF, under the CNCF, Cloud Native Computing Foundation, that is a standardized way of collecting traces that is vendor agnostic or tool agnostic, and it's also agnostic of the analytics backend that you're going to use for visualizing, just a standardized way. Ultimately, by the way, it's going to be used for metrics and then logs, but back then it was GA'd only for tracing, so we chose it for tracing. And to collect, we needed to do 3 steps. One is to install the OpenTelemetry collector. Then we needed to install in Jenkins the OpenTelemetry plugin for Jenkins. And then we needed to configure the Jenkins OpenTelemetry plugin to send to the OpenTelemetry collector endpoint in OTLP over gRPC protocol. That's as simple as that. So that's the collect phase. Then the store phase, as I mentioned, we use Jaeger as backend, so we needed to configure OpenTelemetry collector to send the trace data to Jaeger. And essentially in OpenTelemetry collector, the trace data is aggregated and then sent to Jaeger backend. As I mentioned, we have our own distributed tracing service based on Jaeger, so we sent it to our managed Jaeger. But if you run your own, it's just a matter of choosing the exporter on the YAML configuration, defining the exporter to your endpoint with your protocol or your usage. So whether you use Jaeger or Jaeger compatible or any other, by the way, distributed tracing tool, it's just a matter of configuring the exporter from the OpenTelemetry collector. And by the way, if you don't have Jaeger in production, you want to start playing with that, I wrote a guide to deploying Jaeger on Kubernetes. I put a quick link here. If it's helpful for anyone, you feel free to take a screenshot on this one. And then after we have all the data, then after store comes visualize. And in this case, it's much easier because you don't need to invent the visualizations. There is a built-in visualization in Jaeger UI that provides this timeline view. And again, as you can see, it's a very powerful one. You can see on the left-hand side this indented tree structure. It shows you very clearly which step called which step in the sequence. And also on the right-hand side, you can see the bars where you can see for each step how much time that step took. You can see the relation between steps, which steps occurred in parallel, which one occurred sequentially, one after the other. So if your pipeline run takes too much time and you want to optimize, you can see where most of the time is spent and then see how to optimize that specific part. Very, very powerful tool. So that's how we visualized with distributed tracing the Jenkins. But as before, CI/CD is more than Jenkins. So what can we do more? We can later add instrumentation to Maven, to Ansible, and to other tools to get finer granularity of the traces and the steps. In this example that you can see here on the screen, the yellow is actually Maven running on a Spring Boot and some other frameworks that are there. So in this case, what before was one black box long span on Jaeger, suddenly you can open that span and see all the breakdown into the specific Maven steps of the build. So very, very powerful and interesting to look into if it's relevant for you. So we've seen how to add tracing to our CI/CD pipeline with the same steps: collect, store, visualize, and obviously you can also create alerts on the traces as well. And what next? So as I mentioned before briefly, many of the pipeline runs failed not because of the released code, but because of the CI/CD environment. So not code related, but environmental. So we decided to monitor metrics from the Jenkins servers and the environment, the system, the containers, the JVM, anything that can fail irrespective of the released code, so that we can actually catch it very quickly and be able to react to that. And as you know, when you run Jenkins at scale, it means distributed build with multiple Jenkins servers, master-slave architecture. So all of that we needed to monitor. And again, the same flow: collect, store, visualize, and report. So for the collect phase, we chose Telegraph. We use that in production, so we use that here as well. Telegraph, if you're not familiar, is a very popular open source by Influx Data. One of the strong suits of Telegraph is its very rich suite of plugins, and I'm going to mention a few. So I put here at the bottom a link to the plugin directory. Feel free to take a screenshot. And essentially, the collect phase is two steps. One, essentially, we need to collect the metrics from Jenkins. We decided to do it in a Prometheus format. That's the standard way. We also do that for many other of our production environment. So we needed to enable the Prometheus metrics plugin from the Jenkins web UI. So the Jenkins will expose its metrics in a Prometheus format. And then we need to install Telegraph, if you don't already have one, with a Prometheus input plugin to scrape the metrics off of the Jenkins servers. So that's, and then there is a plugin called Prometheus, just look for the Prometheus input plugin, built in, very easy. 2 steps, and we're done with the collect. And then after collect, as before, we have the store. And for that, we use Prometheus metrics for our production, as I mentioned. And so we follow the same for the CI/CD pipeline, and we have our own Prometheus as a service, so we could use that also for the backend, for the CI/CD. But of course, the same pattern that I'm showing here would work with any Prometheus or any Prometheus compatible backend that you have. Essentially, 2 steps. Or 2 options, to configure Telegraph to send to Prometheus. It could be in pull mode, which is the standard Prometheus way, where you use the Prometheus client output plugin, and then it will expose a /metrics endpoint, and then your Prometheus backend can scrape this endpoint. Or you can work in push mode, where you use the output HTTP output plugin, and then push it to your Prometheus compatible backend. And just remember to use the data format of a Prometheus remote write. So pull mode, push mode, depending on your backend of choice. So that's the store phase. And once the data is stored in Prometheus or Prometheus compatible, it's very easy to build Grafana style dashboards on top of it. Here's an example of a dashboard that we created. As you can see, you can filter by build type, build by branch, by machine ID, by build number. So it's very easy to make investigations. And you can monitor with it the system metrics, first of all, the CPU, the memory, the disk usage, the load, the trend over time, everything that you can see here on the screen. Then we monitored also the Docker container metrics. So the container CPU, the container memory, IO, network, inbound, outbound, the disk usage behavior, and of course the status of the containers, the running, stopped, paused containers by Jenkins machine. And of course, as I mentioned, you can filter all of that to investigate a specific machine, a specific build, or a build type, on a specific branch, or any combination of the filters. So it makes it very, very effective to zoom in and do root cause analysis on where the problem lies. Also, you can show the JVM metrics on the Jenkins machine, the standard thread count, heap memory usage, garbage collection duration, and so on. So all the environment was monitored. You can also monitor the Jenkins nodes, Jenkins queues, Jenkins jobs, executors. For example, here you can see the queue size and the queue status breakdown, how many buildable queues, blocked, pending, stuck, the Jenkins jobs, how many executed over time, the breakdown of the job status, how many aborted jobs, how many failure, not build, unstable, whatever, the job duration, and so on. By the way, it was so useful that actually some of our users wanted to have something like that. So we've made some of these available as pre-built dashboards for our users, so that they can actually, in a click of a button, actually get this dashboard for their data as well. So really, really cool stuff. And of course, as before, you can set alerts on these metrics just as you would for any Prometheus type metrics as well. So I want to summarize what we've seen so far. Treat your CI/CD like you treat your production environment. Just like you monitor your prod with Elasticsearch or OpenSearch, Prometheus, Grafana, Jaeger to gain observability for your environment. Do the same for your CI/CD pipeline to the extent that you need the observability to be efficient. And also leverage the same stack. Don't reinvent the wheel. If you have something that works for you and you know it, and it works for you fine for production, use the same stack for observability on the CI/CD pipeline. In our case, just to summarize, we wanted the ability to have aggregated and filtered information from several pipelines, runs belonging to different branches, also to fetch historical data and choose from our own time range and own filters. So we wanted dashboards and aggregated views. We wanted historical data and controlled persistence by us, so off of the Jenkins servers, and to determine the duration and the retention of that historical data. We wanted reports and alerts on top of that data so that we can automate as much as possible. And we wanted the ability to monitor also the flaky tests and test performance in general. These were the goals. And the way to achieve that, as I said before, 4 steps. If there's one thing to take out of this talk, take this: collect, store, visualize, and report. Collect is to instrument your pipeline to get the events, the state, metrics, traces, every telemetry that is relevant. Then store and visualize according to the data type. Elasticsearch or OpenSearch for logs and events, Prometheus and Grafana for metrics, Jaeger for traces. That's for example. And then set alerts and reports to automate as much as possible on top of that data. And I want to take a step back and remember the goals that we set for ourselves. What we gained out of that is a significant improvement in our cycle time, in our lead time for changes. If you remember the discussion about the door metrics, lead time for changes shortened dramatically thanks to that observability. We also improved the DoD experience significantly. Being a developer on duty became much less of a nightmare. Let's put it this way. And it's based on the same open source stack that we know and love, the Elk stack, OpenSearch now, OpenTelemetry, Jaeger, Prometheus, Telegraph. So the same things that our people know. And actually, when we bring on board new developers and new DevOps, many of them also know these popular open source tools. So it's very easy to onboard also new members. It made it much easier to introduce this new observability into the CI/CD to the team. So that's the journey in a nutshell. And I want to leave some time for questions. So I want to, before going into questions, thank you very much for listening. If you do want to follow up, not on the Q&A here, but separately, feel free to reach out to me at Horovits on Twitter, Medium, or probably everywhere else relevant. And thank you very much for listening. And let's move on, if Alex is here to join me, to some interesting Q&A.
I'm here.
Hey, Alex.
Your session, Dotan. It looks like there's no questions at the moment, but if you are up for it, I have a question for you.
Yeah, glad to.
Okay. Well, the things that you mentioned are, I think, valuable even outside of situations where Jenkins is being used. You also mentioned it in your session description. But what can you tell about other types of pipeline platform, CI/CD tooling that might have some of these things already built in?
I'd say it's a very broad question because each tooling has its own suite of capabilities. I mentioned it, I wanted to be fair. I hope that I did justice for Jenkins. I did try and mention the capabilities that come out of the box with Jenkins, and similarly with Circle CI or others. So each tool has its own. In our case, I think we lost Alex there, but I'll wait for him to join. Hey, Alex.
Mm-hmm.
So each tool has some capabilities, but what we found, at least with the tools that we worked with, that it wasn't enough for us. And as I mentioned, it's also not just one tool. So if you want to aggregate observability across several tools, so let's say that you have a tool, it doesn't matter if it's Jenkins or something else, and let's say that it has good visibility into its own capabilities. But as I mentioned, you want CI/CD is more than just Jenkins or Circle CI or other tools. You want an aggregated view across many types of stages that comprise your CI/CD. So what if you want some observability into your Maven? What if you want observability into your, I showed examples of container metrics and system metrics and JVM metrics, and you don't want to jump between two different tools and different platforms for that. You want to have one aggregated view across all of these different signals, across all of these different frameworks that you use in your CI/CD pipeline. So for that, I think that having an external observability platform that just collects this information and then provides the aggregated view across is very powerful. And obviously you can do then a linkage for drill down when you do root cause analysis and drill down into the Jaeger run specifically to get some more information. By the way, we have, for example, the link to the Jenkins run embedded within the ticket that we open when there is an alert. So we do have that, and sometimes we do get into Jenkins to get more drill down. But the aggregated view is what we sorely missed, and that was actually not even well rounded up within Jenkins, not to mention that we wanted beyond Jenkins, as I mentioned, go into additional frameworks that we use in our platform.
Yeah, very cool stuff. Yes. Anything from your side that you want to add now at the end of the session?
I want to invite everyone to really, if you have questions and you didn't want to bring them up here, feel free to reach out to me at Horovits, Horovits, and I'd be more than happy to answer questions or hear feedback or comments or your experience. That'd be great. I also have a good article that I wrote about open source for better observability. So observability obviously is not just about CI/CD, but I think open source presents quite a few advantages, and what are the recommended open source tools and what are the trends. So if you are interested in understanding a bit better, and if you're considering you're in the point in time of vetting tools or choices, I think it could be helpful to check this out. And again, you're all invited to check out my podcast, Open Observability Talks, where I discuss many of these tools and frameworks and invite some maintainers of the open source projects and people who are well versed with these that can shed a lot of detailed information about the different tooling, OpenTelemetry and Prometheus and Grafana and many others.
All right. Well, thanks for those invitations. I hope people will follow up on that. With that said, thank you for your wonderful session and all the insights that you have shared. And audience, also thank you for listening in. This is the final session in the serverless track, but obviously you're free to switch tracks and enjoy the last session of the Dev Days Europe 2022 conference. Hope you enjoyed it, and take care, be safe.